The sun is the superpower of our solar system.
It can be the same massive flying out into space. pressure and such high density at the core of the sun that the two objects impacting each other will actually fuse.
In the sun, these objects are hydrogen atoms clung together by immense pressure to form helium atoms. In this fusion process, the resulting atom is slightly less massive than the ones that created it. The missing mass is given off as energy. Each second inside the sun, 600 million tons of hydrogen are fused into 595 million tons of helium. That 5 million tons of mass lost in the process is converted into energy equal to 1 billion 1 megaton hydrogen bonds. That's every second.
When you look out into the cosmos, the process that gives you the highest return of energy for free is what goes on in the centers of stars like the sun.
So we now know that the sun is powered by nuclear fusion. It's the only fuel that we know that can sustain the burning in the sun long enough to sustain life on Earth. Billions of years.
Sunlight. It's so central to life that we don't often give it a second thought. But how light gets from there to here turns out to be an incredible story. The energy created in the fusion process is carried out of the core by particles of light and heat called photons. They are what bring the warming rays of the sun to Earth. To reach our planet, these glowing travelers from our nearest star must first take a long, winding road through all the layers of the sun, like Dante journeying through the levels of hell. First, a photon enters the 185,000-mile-thick radiative zone. The region is so densely packed that the photon constantly bumps into other particles, like hydrogen and helium atoms. It struggles outward in a chaotic zigzag pattern that scientists call the random walk.
A photon can't escape without interacting over and over and over and over again, getting absorbed by atoms and re-emitted, and it can be absorbed and re-emitted millions of times. As the density decreases,